Hello guys, welcome back. In this video, we'll implement a simple retrieval-augmented generation. In the retrieval-augmented generation, when you are asking question to the LLM without having any context, LLM tries hallucinating the information. Hallucination is where the LLM tries to give the incorrect information, which is not at all valid in the context. And that is the reason to get the more accurate answer, we get our context, which is our data source, and we'll pass that as a context to LLM to get the right answer. There are two aspects of this RAG. One is a document processing and indexing. Another one is retrieval and response generation. In the first part, document processing and indexing, we get the data source. Data source could have maybe the PDF files or something like a URLs or something like a TXT files, or could be any type of files that you want to get the information from. We split that data by using a document loader. So document loader is a class which loads the data and splits it into different chunks. Those chunks later will get converted into embeddings. The embedding is a numerical form of the data, which will be stored in a database like a vector database. So precisely, the vector database stores our knowledge, and that knowledge will be used later in order to get the right answer. The first aspect of it is where we are kind of getting the data and storing into vector database. Later, when the user asks the question, let's say user is asking a question, I know the answer is there in the vector database, so I'll go for a retriever component, which will go to the vector database and get the data from it, of course related to the information which is required to answer the question. Then this context or this information will be passed to LLM along with the user query. So LLM, using its knowledge with our knowledge that is passed from the vector database, will try combining the answer. This is what we are calling as a response generation, and the final response will be sent back to the user. So in this case, we are trying to not avoid, but try to reduce something called as hallucination of RAG. Let's start implementing it. Let's start implementing this application. This application name is Chat with PDF. This is a very simple application. The concept is like you get the data source like PDF file or files, and we'll ask the questions and we'll see if the LLM application can answer the questions based on the PDF file. To do this, we are going to split the application into two parts: the document processing and indexing, and second one is the retrieval and the response generation. So let's start implementing document processing and indexing. For demonstration, I've created a file with a dummy information of a person named John Doe. This person is said to be a DevOps engineer and machine learning expert. Summary, contact information, education. This is a made up resume using a ChatGPT model. So let's use this as my data source and ask a couple of questions and see if my LLM can answer the question. Let's go here and create a file. Let's create a file named chat with pdf.py, and let's see what things that we need to do. Now first thing, let's install the required packages. So maybe I can say install required packages. You need to install them before you run this application. So you can say pip3 or pip depending on which operating system you are using. For Windows it is a pip, for Mac and Linux it is pip3. Install LangChain. LangChain is the mediator between the application and something like a LLM. Okay, so this is the one with which will help us to connect to the LLM. Now there are multiple LLMs available. You can go for OpenAI, ChatGPT or Anthropic Claude, and there are multiple options available. But at the moment I'm using Ollama. So you can also download the Ollama on your machine and start running LLM locally. So if you go back here, you can say Ollama LS. I'm using 3 different models: Llama 3.1, Mistral and DeepSeek R1. Out of that, I'll be using Llama 3.1. So let's start implementing this application here. Oh, before that we have to install the LangChain for the Ollama by saying langchain_Ollama. If you look at the diagram, we are using a vector store or vector database. That vector database will be provided by Chroma. So we can install, or we have to install that also. It's like a langchain_Chroma. Again, we are going to use the PDF files. So to load them, we are going to use a document loader. So document loader is something like PyMU PDF, and then it will install all the different required packages on your machine. Let's create this application into 2 different parts. Like the first part is going to be document processing and indexing, and second one is the retrieval response generation. So I'm going to create the functions accordingly. This is my first part. The name here is document processing and indexing. So maybe I can say load documents and create vector store. So let's start step by step. Let's first import the required classes, like from LangChain community dot document loaders. We are going to import something called as a PyMU PDF loader. We already have installed PyMU PDF, so this will help that this will help us to load PDF file by using PyMU PDF. So let's say create the loader by saying loader is going to be equals to this PyMU PDF. The file path is going to be equals to ./profile.pdf, and then load the document. So load the document by saying document is going to be equals to loader.load. This will load the document. Now what I'm going to do with this, let me add one more part inside this diagram and say once the document loader loads the document, in between these two we are going to use one more part. I didn't mention that earlier, but this is needed in order to convert that into the embeddings. This is called as a splitter. Splitter is going to split the document loaded by the document loader into small chunks. So those chunks will be adding inside the vector store. So this is how it will look like. So this is my splitter. Let's use this color and say this is my splitter, which is going to split the document into small chunks. Chunks means parts. Now to do this, I'm going to go back here and say from LangChain dot text splitter, we'll be using recursive text character splitter. So this is the splitter format. So I can say create the splitter by saying splitter is going to be equals to recursive character splitter. This is like the chunk size. I mean, how many characters you want to put in one chunk? I'll say 1000, more than sufficient. And there is a chunk overlap. Now this overlap means how many characters you want to make common between two different chunks. I'll say 200. So the idea here is the first chunk will have 0 to 1000. It's like 0 to 999, and later in the next chunk, instead of starting from 1000, we'll go for something like 800, and then 200 will be common between the two chunks. So that is called as a chunk overlap. Now that splitter is going to be used for splitting the document into chunks. So maybe I can say create the chunks by splitting the document. This can be done by saying chunks is going to be equals to, this is the splitter dot split the documents, the one that we have already have loaded, called as a document. So we have got the chunks. Now we want to put those chunks loaded by the document loader using that splitter has created those chunks, and those chunks we want to put them inside the vector database. Now to do this, we are going to need the chroma DB, plus we are going to need the embedding model. So let's import both of them here. From LangChain chroma, import chroma, and we also need the embedding model. This can be done by saying LangChain ollama, import ollama embeddings. So this is the embedding model, or you can call it the embedding function, which is going to convert our chunks into different indexes, different embeddings. Coming back here, I can say create the embedding model by saying embedding model, which is going to be equals to ollama embedding, and use the model. It's like llama 3.1. I showed you earlier. I'm going to use the llama 3.1 LLM for this demonstration. Now we can say create the chroma store to store all my embeddings. Can be done easily by saying chroma underscore db, which is going to be equals to chroma, and right inside this, let's start where you want to put it. I want to put it in my current directory with the name ragdb. Next we'll say what is the collection name. So collection name in my case could be this is like a person info. You can put any name there, doesn't matter. Think about this like the table name, which is going to have the information about the different entities. So in this case, the person info is going to have the different chunks from that PDF file. The embedding function, important one, because this is the one which is going to convert your chunks into embeddings. In my case, this is the embedding model. And I think that's it. I don't think anything other than that is needed. Let's confirm that. The required functions we already have passed, so I think we are done. Now what? Now this chroma db is going to create a new directory called as a ragdb in my current directory, and will create a person info collection, and in that collection I want to store all my chunks. So maybe I can say add the chunks. This can be done easily by saying chromadb dot add documents and the chunks that we have created last time. That's it. So this is the first function, load document and create vector. Let us see what happens. If I go back here and say ls minus la, I don't have any directory called as ragdb. So the moment I do this chat with pdf.py, it will take a minute because it needs to first load the document, convert it into different chunks. Every chunk will get converted into embeddings, and those embeddings will be stored inside the chromadb. So in a minute or two, you will come back here and you will see one directory is created. The directory already has been created called as a ragdb. Inside that you can see there is a file called the chroma.sqlite. All these chunks are stored behind the scene using a SQLite database. We don't have to really worry about that SQLite database because the chroma will handle the insert or retrieval part on its own. So we really have to worry about nothing. The application is created, and if I look at this, if I look at this again, maybe ls minus la, you can see there is a ragdb, and inside that ragdb the data already has been loaded. Now we are done with the first part of it. So in the diagram we can say the first part is completed. Now let's look at the second part. The second part starts with the retriever. So retriever is the one which is going to retrieve the data or the relevant documents from my vector store. So this can be done by creating a separate function. Maybe I can say retrieve documents and generate response. That's it. Now we have to create a retriever. So to create a retriever, we need to load that chromadb. So this means we have to again use that chroma, like what I did last time, and say this is going to be like chromadb, which is going to be equals to chroma. I think I can directly pass all the parameters that I already have passed earlier. So better for me to copy this part here and load it there. That's it. We need the Ollama embedding. So we can say langchain Ollama import Ollama embeddings. Now the chromadb is loaded. I can say get the retriever by saying retriever is going to be equals to chromadb as a retriever. So this will help me to retrieve the documents, relevant documents from my vector store. Let me give a small example of it. Say for example, this is my query given by user. Say for example, what certifications John has completed. So let's see what kind of related documents I can get here. So it's relevant documents I can retrieve by using the retriever dot invoke and pass that query directly. Okay, and let us see what it's going to give me back. So maybe I can say print relevant documents and see what does it do. So this is my retrieve document and response generate or generate response function. So let's go back, run this code. It will go to the database, that's vectordb, and it's going to find out the similar documents to answer that question, and it already has found out certain documents here, right? If you really want to put it in a better way, you can run a for loop and say for, maybe I can say doc in the relevant documents, relevant documents, and print the doc dot page content. So the page content is the one that will give you the actual information from that document. Let's put a line of 80 characters so it can be easily shown you, like first context or first document, second document, so on and so forth. So you see the first document is from here to here, the second document is here to here, third document is here to here. So these are the documents it has retrieved from the retriever. To be honest, we don't have to worry about that right now because all these related relevant documents will be passing to the LLM, and LLM will answer my question. This is not the final answer, so the final answer will be given by LLM. To do this, we are just finding out what the relevant documents can be found out from vector store. Okay, now I think better for me to run this as a while loop. We can say while true means it's going to be like the infinite for loop, because I want to get the query from user. So query is going to be equals to input question. We'll ask user to enter the question here. So the user will enter the question, and that question maybe I can store it here as a question. Okay, and then we can go back here and get the related documents. So I can say find the relevant documents from vector store. Okay, that's done. This isn't needed, so we can just remove that. Okay, so now we have to talk to the LLM, which means we have to first create LLM, right? So maybe I can come back here and say from LangChain Olama import chat Olama and create that LLM. So maybe I can say create LLM by saying LLM is going to be equals to chat Olama, and again select the model. In my case it is Llama 3.1, sorry 3.1. That's it. So now we are having LLM, we are having the question. Now let's create a prompt and ask the question and get the answer. So this is where we are going to say create the RAG template, prompt template rather, prompt template. So maybe I can say RAG prompt template. So the template is going to be very simple. We are going to set the system context here by saying hey, you are, I'm asking LLM right now that you are an assistant who will answer users questions. Okay, now use the context provided to answer the question, answer the questions. Okay, now very important, please maybe I can say do not create any fake response if you can't answer the question. So let's say if you cannot answer the question, please do not create any or do not make up any answer, or do not create any wrong answer, or do not create any fake answer. Instead say you cannot answer the question. Okay, very important point. Otherwise if it does not find the information, radio information, it may be start hallucinating again. So the main reason why we are going for RAG is to reduce the hallucination. You can't remove it, but you want to reduce the hallucination. So this is the important line here. Okay, so do not create any fake answers. Okay, and try answering the questions in details, in sense we want to get the detailed answers. Okay, now we need to pass the question. So this is the parameter 1 question. We need to set the context. So this is the second parameter, context. Okay, and what we are expecting from LLM is the answer. So that becomes my RAG prompt. Okay, now coming back here, I'm going to go for creating a chat prompt. So create a chat prompt template. Fine, so I can come back here like this. I can say from LangChain Olama, sorry, LangChain.prompts, we can import chat prompt template. So this is the prompt template which will be using my prompt template, where we are having two parameters, question and context, and we'll fill up those information, fill up those 2 points, and then we'll pass that to the actual LLM. So where I can say chat prompt template, which is going to be equals to chat prompt template from the template, the one that I've just created right now. It's called as a RAG prompt template. And then here, when this is going to be like common to all, now here I'm going to create the actual prompt. So create the prompt. Okay, so we can say the prompt is going to be equals to this, like a chat prompt template dot invoke the chat prompt template dot invoke. Maybe I can go back here and pass the parameters. This is my question asked by user, this is my context, and the context I set there. So I think the context we already have created here. Probably I don't have the context. Sorry, we'll have to first create the context. The retriever has too many documents, so maybe I can say create the context, not here, my bad. We have to do that here after getting the relevant documents. So maybe I can say create the context. Context is nothing but a list of the information that we have retrieved from the retriever. So create the context. Maybe I can say the context is going to be equals to, split it by using /n character. Say join the relevant documents we saw. It was an array, so we already have printed that last time. So we can just go back here and say the doc dot page underscore content, where we can say the for doc in the relevant documents, right, like that. And then we can set the context here. So now we are having the right prompt. Just ask the question to the LLM and get the answer. So get the final answer from LLM. Okay, so this can be done by saying result is going to be equals to LLM dot invoke and pass that prompt. That's it. Then we can say print the result dot content, and then we can print a dash 80 line, so at least we can see where it stops and where it goes to the next line. Okay, we can also print one more empty line, and then it's in a for loop, it's in an infinite for loop, so it's going to keep on asking the question. Let's say if the question, this is like a terminating condition, so when we will stop the application, so it's like a terminating condition. So if I say the question asked by user, if it is an exit, or if question is going to be equals to exit, or maybe I can say the question asked by user is like quit or exit, any one of them, then we can say the break means we are going to stop the application here. Simple as that. Okay, now it's a kind of, you can say it's like a bigger function that we have created now. Let's see if it really works. So going back here now, oh, I'm getting an error. What it says, it says a field required, type missing, import input values the prompt template. Let me see what it is telling me here. So chat prompt, oh, I'm using a wrong one, sorry, it's not the chat message prompt template. While importing it, I imported a wrong one. This is chat prompt template. Okay, now it is fine. Let's go back, run this application. It's asking me the question. Hey, what's the question? I can say what certifications John has completed. Let's see what answer am I going to get from LLM. So this LLM is going to get the retrieved documents or relevant documents from the retrieval, and from that source it's going to answer my question. So let's hope this will give me the right answer. Cross your fingers and see. Oh my god, look at that, I got the right answer here. So the John has completed those three certifications, and which is absolutely right. You see, if I go back to my document, I can find this information somewhere here. CDE, CMLE and CISSP. Yeah, I got the same answer. That's very right. Let's ask one more question. Okay, what's the education background of that person, John? So what is education background of John? Okay, so in my case it seems like there's a bachelor degree and master's degree from the, let's say University of Michigan and New York University. Oh, look at that, it also has answered the question in a right way. So according to the provided context, the bachelor's degree in computer science and master degree in data science. Absolutely right, absolutely right. Let's ask the last question now. Maybe this could be based on the skills. Okay, this person knows Python, Java, C++, JavaScript and R. So let's ask the question, which languages are known to John? Let's see, using a different tone right now, let's see if it can understand my context. And languages means like not the English or the regular languages, like a programming languages. Look at that, it also has answered the question with its best knowledge. Python, Java, C++, JavaScript and R. Is that right? Of course yes, this has to be the right answer. It's LLM, it has understood the context, and based on the context it has answered my question. I think I'm done. So if I say quit or exit, it will stop my application. And yes, you saw that by using this documents, we have built our vector store, and using the vector store we answered every question asked by user in a right way. So by using the context we could answer the question in a best possible way. This is called as a RAG or a simple RAG. Now there are a few problems with this. It cannot store the memory, or it doesn't have a memory. It cannot understand what question I have asked earlier. We are going to fix that in upcoming videos. Again, thank you very much for watching this video. If you have understood the concept of RAG, if this video has given you some knowledge, please try subscribing that channel and try hitting the like button. Again, thank you very much for watching this video. Bye bye.